Alright, I'm Case Rowan, and this is problem 2 through 4. Okay, so we have a guy in a pulley here with a downward force for his weight, and we have his pulley that he's on, and there's a second rope coming off the pulley going to the left. So we're gonna assume that he's in equilibrium, so both the forces in the X and the Y are zero.
That's an assumption that we're making?
That is an assumption we're making, yes. And then we're going to get the components of each force here. So for the X, we have the component on the right side in the positive direction. We're going to say that, I guess, X is positive to the right and Y is positive up. So the rightwards component of the tension for ACB is TACB cosine 10. And
it doesn't matter which way that you assume these, as long as you're consistent, right?
That's true. Good point. So then we're going to subtract TACB cosine 30 because it's to the left, if we're assuming that X is to the right positive. And then we also have to consider TCD, the tension of the second cable on the left.
Oh.
Yeah. I make that 0.
Yes.
All right, that's halfway done. Forces in the Y. All the tensions are actually going upwards. So we got the tension on the right side, or I guess left side, sine 30 here. On the right side, TACB sine 10 here, and then TCD sine 30 here. That counterbalance with the guy's weight of 140 newtons. So now that we have two equations with two unknowns, we have a system of equations, and we're going to isolate TCD on the top here. So TCD, we now know, is 0.137 of TACB. So using this information, we can plug it back into the second equation and get it all in terms of TACB. And then solve for TACB, which is 188.5 newtons. And using this information, we can just plug it back in here and find that TCD is 25.83 newtons.
Okay, that makes sense. I think when I did this problem, I think the hardest part was just like seeing that like TACB is like the same tension on both sides of it.
Yeah.
Even though it's like one of them's negative because it's going in the opposite direction, even though it's like the same tension.
I did run into that problem too, but we can see that, you know,
with that too, yeah.
It's a left side and a left side component, you know? You gotta split it up. Any other questions here?
I just want to let you know, like, I struggled with that part.
Okay, I'm glad you put that out. What was your name again?
I'm Evan.
Evan, nice to meet you, Case. Alright.
Alright, should we move on to the next problem? Alright. So this is problem 11 and 12. This is the boat problem. So we're given that the tension in this guy wire is 306, and we're given that it has a 20-degree angle with the mast. And so I think the immediate idea in my head was to go to a free body diagram, but you actually don't need to do that. You can just develop it into two different triangles. The key distinction being that this side of this triangle is going to be, so this is the guy wire, and then this is the mast. So this is this triangle right here.
Yeah.
Okay.
And then this side, this sine component of that triangle is going to be equivalent to right here, which is going to be a triangle right here.
Oh, okay.
And so that's going to be how you get your X, Y, and Z components. And then from there, you can just use the components to figure out the forces. And then when finding the angles, you can just go ahead and use this equation where the force and the direction is equal to the net force times the cosine of that angle, respectively.
That's derived from the...
Oh, yes. Yeah, that is derived from I think it's like f of x over f is equal to...
And we can use that for, like, any x, y, z...
Yeah. So that would be just change the x's, yeah. Mm-hmm.
Okay.
Yeah. But yeah, and I think also something to note is that the resulting z and x's are going to be negative because the tension from this wire is going like upwards, so it's pulling on the boat. So that means, and you can only kind of get this from looking at the diagram, but it's going to be in the negative x direction and the negative z direction, and then in the positive y direction.
That gave me some trouble when I tried that one.
Yeah.
That was hard.
You have to look at the diagram because if you're just doing it mathematically, you're not gonna catch on. All right. Anybody else have anything? Any other comments, questions, concerns?
No, that actually made a lot of sense.
Dude, I was like understanding that.
Okay.
All right. Dude, holy. Evan, wait, how did you... Wait, let me fix the desk. Shit.
Please abstain from swearing. Don't just swear in this class.
That'll be like,
Okay, there we go. Yeah.
my bum.
Wait, are you the red or the...
I'm the red.
Okay,
above
okay.
me. Alright, so I'm Evan. I'll be explaining problems 5 through 10.
My name's Andrew. I don't know if I said that.
Did you get your name too?
I got my name.
Okay.
Go ahead.
So in this problem, we have a crate being pulled up or held in position by one pulley with through different arrangements. So in arrangement C, we have 3 tension forces holding up the weight, and from that we can set up the equation 3 tension forces is equal to the weight, and that's just one tension force for each.
Is there just like that was just one pulley?
Yeah, so it's
okay.
one pulley, but the rope holding it up wraps around it multiple times. So like this one is the left end of the pulley where it wraps around, the right side where it wraps around, and then it connects back in the middle.
Okay,
You can
gotcha.
assume they're all going upwards too.
Yeah,
Okay.
that's the only part that matters for this. So we could set up 3T is equal to W, where W is 530 pounds. And then from there, just solve for tension, which is 176.67 pounds. For arrangement D, there's a slight difference from where the rope goes off, but it doesn't actually matter because we still have the same 3 upwards forces in the same spots. So we end up getting the same exact thing.
So this is like a simplified drawing of the arrangements.
Yeah.
And for all of these, we can assume that the tension is distributed evenly.
Yeah. And so those assumptions are that there's no external forces and that the rope is massless. When we assume those things, we can assume that the tension is completely evenly distributed.
I really like massless ropes.
Oh yeah.
They're so helpful. And then, so we have arrangement E, which is slightly different because these 2 down here and then these 2 up here, those are actually 2 different pulleys.
Oh yeah, I think I remember that one.
But it doesn't make a huge difference. We just need to include 1 extra tension because it's going to pull up from 2 different spots up here and then from 2 different spots down here.
Okay.
So the only change is that instead of 3 tension forces, we have 4. So we just divide that out the same way, and instead of 176.67 pounds, we get 132.5 pounds.
So instead of, even though these 2 are connected to one pulley and then these 2 are connected to one pulley, the net weight is still connected onto this evenly basically.
Yeah, all we care about is that these are pulling upward at these positions.
Yeah, okay. Yeah, that makes sense. I remember
Okay.
that helps. All right,
Nice.
good.
Thank you.
Good job.
Next, I'm explaining. My name's Thomas. Thomas Brandt. Group 3. So I'm presenting questions 13 and 14. It's 2-parter. So we're given theta x is equal to 72%, and theta y is equal to 153%.
Degrees.
Degrees.
It's okay. It's okay.
Keep
going.
And then we have a z component of the force is negative 52 pounds. So basically, for 13, they're asking us to determine the angle theta z. So we're going to use this equation, which we're talking about today, actually, in class. So it's a cosine squared theta x plus, you know it. So now we're isolating the part of it with theta z, because that's what we're solving for. And then we do that, and then we get a square root. So then we get a plus or minus. Which I think you had a question about.
Oh yeah. So okay, so I noticed you have the plus or minus, but you only cared about the minus. What's up with that?
Yeah. So if you
What's so funny, Professor?
come to my office hours and I'll tell you. But for now, we have so if you plug in plus here, you would get a different degree value. So only one of them can be correct. So
you can have 2 different degrees. Yeah.
in this case, because our z component is negative.
Oh, so since the z is in the negative, it's a negative magnitude.
That took a long time to figure out, huh?
That took us a
actually
while.
did, yeah, it
that
did.
was
Yeah.
Many
hard part,
many
yeah.
tries. So we're gonna do that negative, and that will give us the answer 109.426 degrees.
Thank you.
And then for question 14, we're solving for these 3 things. We got magnitude of the force, which It was tricky at first because they don't tell you it's the Z component, but it pretty much is.
Oh yeah, I think I remember doing it and thinking the 52 is like the total component. And
Yeah,
not
yeah,
the
yeah.
Z, like not the Z.
I did that too at
yeah,
first.
Yeah.
It's a tricky one.
I didn't do that.
So-
Not an issue.
See me after class. So we're using this equation for all three of them, pretty much. So we have f of z is over f is equal to cosine theta z. So we're solving for f. That's the magnitude of the force. We're gonna plug in our given, so we're given that magnitude, and then we solve for theta in the last question. It'll give us 156.34 pounds. For the x component, we're doing something similar, except for our f here, we're going to use the magnitude we solved for.
Oh, so you use
right
the
now.
previous magnitude and plug it back in?
Yes, not the negative 52 pounds.
Because you solved for. Whoa.
You have white pens.
I do have white
He
pens.
has white pens on. We're good. We're good. We're good.
Oh no, it's overweight.
Thank you. So yeah, that'll give you 48.312 pounds, and then for the y component, we do the same thing, and that will get you negative 139.299 pounds. Class dismissed.
Wait,
We
should-
have some students that might have any questions. You
I
guys,
hope not.
can you explain that again?
All right, should we just say our names like one last time for the video? All right, I'm Andrew Thompson.
I'm Case Rowan.
I'm Thomas Brandt.
I'm Evan Fogel.
And we're group 3.
That is.
I don't know who this is.
Okay, bye.